Yeah, enough. You know it's recorded. I can send it to the AP anytime I want.
Shift.
Speaking of flipping and shifting, what if we want to solve for x instead? Is this x equals to y plus 1? For this one, could we rewrite these? This is y is equal to plus or minus the square root of 3 minus x. Square both sides and you get y squared equals 3 minus x. So x equals 3 minus y squared. That is a parabola that has been reflected and then shifted. Shifty little thing, isn't it? Oh. So now that I have them both in terms of x, could I set them equal to each other? And then, Jed, are you going to have to factor again?
I'm good at that.
after the warm-up and the quiz? So I have y plus 1 equals 3 minus y squared. Shift everything over to the left. Terms to the left instead of boxes to the left. We get y squared plus y minus 2 equals 0. Can you factor that for me? Yeah, okay, the correct answer would be yes, whether you can or not. Lie to me.
I got it. Ready?
What is it?
Y minus 2 plus 1.
Y minus 2, really?
Y plus 2.
That would be better. Is that going to work out better? Yeah, so what is my y? My point of intersection, my y is at negative 2, or my y is at 1? Notice it's y's now. If I have the y's, can I go plug back into one of the equations to get the x? Now, if you have a choice between a linear and a quadratic, which would you plug into? Linear. Okay, don't do this the hard way, right? So if I plug back into the linear, remember what my linear was? My linear was x equal to y plus 1. Plugging in, is this x? When I plug in negative 2 into this, what's my x? Right? And then for this one, what's my x if I plug in 1? 2. Do I have 2 points of intersection now? Yeah. All right. We need to graph these also. So let's go make some XY tables. So this is for the, we're gonna say for the red, we're gonna make this one x is equal to y plus 1. Okay, and we're gonna go, all right, I already have 1 point. So this is my x, this is my y. And I already know it's going to go between these. So do my y's, if my x's are going between negative 1 and 2, or my y's going from negative 2 to 1. So I'm going to plug in negative 2, negative 1, 0, and 1 for my y. Then am I going to plug it into this equation? I already got this one. If I plug in negative 2, I get negative 1, yes? Plug in negative 1, I get 0. Plug in 0, I get 1. Plug in 1, I get 2. Right? Then I'm going to do the other one. This is x is equal to 3 minus y squared. Plugging in the y's, because I have the y's. Why? Why? Because I have them. So I have negative 2, negative 1, 0, and 1. Hang on, sorry, a little messy. I know the negative 2 gives me a negative 1. These match. Notice those points of intersection match. They should. Plug in the 2, the 1 down here, I get a 2. That matches. That's good. Now plug in negative 1. Negative 1 squared is 1. 3 minus 1 is 2. Plug in 0, I get 3. Can we graph these points? Yeah, and we get our curves. And then I'm going to show you how painful it is if you keep it in terms of x's. And then I'm going to show you how, with a simple flip of the variable, if I use this when I solve for the x's, if I use everything in terms of y, it is so much easier. But you'll have to think. Oh my. So we're going to graph it now. Are we okay with that? I got just enough room to graph it, I think. So I want 1, 2, 3, 4, 5. I need 6, so. So for the red, I have negative 1, negative 2. Oh, I need red. And then 0 is negative 1. Oh, this is that line. That's easy. Right? There's my line. And then for my parabola, I have the same -1, -2, and I have the same 2, 1. I have this and this point, right? And in between, I have when x is 2, y is -1. When x is 3, y is 0. And is this my parabola? What? What did I do? I plotted the points already out on my table. It's sideways because this equation right here. I did it in terms of x equal to a y. I did everything in terms of y to graph this. But we're about to solve this in terms of x. So do I have to do this all in terms of, so I'm going to change this right here. I'm going to make this one green because this is now, this is f of x. It wasn't an f of x. No, it's g of x. G of x is equal to the square root of 3 minus x for this curve. For the blue one, which is this one is h of x is equal to negative square root of 3 minus x. This is doing it in terms of the three things they gave me. And this line right here, that is f of x is equal to x minus 1. Do you see a problem if we're going to do this like we did yesterday? Yesterday we did upper minus lower. Let me show you what I mean. So right here, upper minus lower, all good. Upper minus lower, all good. All upper minus lower is the line over the lower radical. Oh, what happens here? Uh-oh! I have to change. My upper is different. So what happens is right here you have to change, and you have to break it into two regions. To the left, it's the line over the lower radical. To the right, it's the positive radical over the negative radical. OMG. Do you see why this is a real pain? Because I have to write two different integrals, and it's not that bad, but it's going to be messy. It's going to be very messy. So we're going to set it up, but we're not going to integrate it because it's messy. Because am I integrating radicals? What a pain in the butt. It's U sub. U sub of 3 minus something, that's going to be negatives, and y'all are going to lose. Oh, nasty, nasty, right? So let's set it up, and then we're going to go on, and I'll show you an easier way. So for this one, this is my region 2. For L2, what is L2 equal to? I'm going to redo that. L2. L2 is equal to the upper, which is this one, minus the lower, minus a negative square root of 3 minus x. Does that mean I have two of those radicals? L2 equals 2 square root of 3 minus x. Yes? And then on this side, what's L1? The line, x minus 1, minus the lower radical, which means minus the negative, is that plus the square root of 3 minus x. OMG. And what are my limits of integration? For this one, I'm going from -1 to 2. For this one, I'm going from 2 to 3, right? Do y'all see that? Can I go to the next page? Yes? I'm going, nobody's screaming. Okay, so where did we get to? Our area is equal to the first integral. I am integrating from -1 to 2, right? Of L1, which is x minus 1 plus the square root of 3 minus x dx. OMG, I do not want to do that with y'all. And then it's plus, come back here, plus the integral from 2 to 3 of 2 square root of 3 minus x dx. Royal pain. Do you agree that that's a painful thing? Would you like me to get this so that it's in terms of a polynomial, a quadratic, exactly? Since y'all like to factor them so much, right, Chet? We're going to get it in terms of quadratic. Watch the magic. We're going to regraph this and look at it a little different way. We're going to look at it in terms of y instead of x. So really fast, have y'all got that written down? Really fast, we're going to graph this again. We're going to do the same graph. So for my line, put my line down. It was starting at 0. So there we go. There's my line. Just drawing my line in. That's f of x. But we're going to do it in terms of x's now. This was x equal to y plus 1, wasn't it? If we do it in terms of x's. So the parabola was at 1, -2, and then at x of 2 it was -1, and 3, and then this. Here's my parabola, right? Yes? Do you see that the blue is always to the right of the red? This parabola, that parabola is x equal to 3 minus y squared, yes? Notice these are both in terms of y. If I do Riemann sums, if I make my rectangle sideways, watch this. Right to left, 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 nothing flips. This length right here, this length, is it going to be 3, so hang on, let me write. That length is going to equal to the 3 minus y squared, which is the right curve, minus the y plus 1, which is the left curve. If I always do the rightmost number minus the leftmost number, will I always get a positive length? I'm getting a value that's more positive minus a number that's less positive. I will always have a positive number. Isn't that amazing? Really, really. So in this method, I always want right minus left. If you look at that Riemann sum right there, if you look right on the end, is that a delta x? Is that, I mean, not a delta x, it's a delta y. Is the width of this rectangle a y? Okay, I have functions in terms of y. It's not really, it's functions, but it is, but it's, turn it sideways. I have all my equations in terms of y. I have my width in terms of y. What do I want my limits of integration in terms of? Y. So am I going to start it, we're going to call this c. Is c going to be -2? And I'm going all the way up to here, which is d, and it's 1. So my limits of integration are y's. My function, my equations are in terms of y, and my width of my rectangle is y. Can I do this whole integration in terms of y? Watch what happens. You ready? Has everybody got their figure drawn? So this area is equal to the integral from -2 to 3 of 3, okay, can I simplify that, by the way? Can you simplify this? Is my length going to equal to, is it going to be 3 minus 1 is 2 minus y squared? Is that going to be a heck of a lot easier to integrate than x with all that stuff in a radical? Watch this. I'm not going to do that. I'm going to actually have it simplified. I already simplified it. So it's going to be 2 minus y squared dy. We can integrate that right now. What's the antiderivative of 2 in terms of y? 2y. Why ask why? What's the antiderivative of -y? -y squared over 2. What's the negative? What's the integral? I mean, yeah, the antiderivative of -y squared. -y cubed over 3 evaluated from -2 to 3. Plug it in. Plugging in 3, it's going to be 6 minus 9 halves minus 9, because 27 divided by 3 is 9, minus plug in 2 is going to be 4, minus, well, 2, put a -2 in here, it doesn't matter, it's 4 over 2 is minus a half. No, it's minus 2. I'm going nuts. Right? Because 4 over 2 is 2. Then put a -2 in here, and does that become -8? So it becomes a positive 8/3. Yeah? Huh? Yes, it is. It's -4. I already did the minus. I was getting a little ahead of myself. What, Jet? You got it?
Oh no, I was giving Jet a high five.
Okay. Okay. Does that give us 10? Right? 4, okay, hang on, I didn't write. 4 and 6 is 10, minus 9 is 1, right? So I took care of that, and that. Oh, I got my -2 too. Hang on. No, so it's going to be 3. So this becomes a 6. That's a 12 minus 9 is the 3. 3. Took care of all those. All the whole numbers. Well, then I got 9/2. So I got a -9/2. And then I got a -8/3. And I could get this in terms of 6, but I don't feel like doing it right now. That's good enough. Woo!
That was easy.
What?
I'm still confused on the limit. You're doing it in terms of y, right?
Yeah.
-2 to 3.
Yeah, do you see right here that my y value here is -2? And then my y, oh, it's 1. Because I was an idiot. So it's -2 to 1. Y'all got, sounds like a personal problem. It actually makes the math work out better. Y'all can finish that on your own. Oh, I'll finish it. That's going to be 4, right? -1/2, and then 8/3 minus, so it's -9/3. That's a -3. So that's a 1/2. Let's see if it works. I'm going to do it in the calculator. Woo! Math 9, going from -2 to 1 of 2 minus x minus x squared. I did something wrong. It should be 4.5. Hang on, did something wrong. Oh, the 2, 8. Yeah, so that's 8. -3 minus 1/2 is 4.5. It's bad math day. I'm not firing on all cylinders today. Okay. That, by the way, that 4.5, it should look really familiar because it's going to be all over the place. You're going to get that answer a lot. Because I can take this shape and I can rotate it and reflect it and shift it all over the place, and it all looks like a new problem to you. I can.
Just skip all that and write 4.5.
No, because it's called a bald answer, and you'll get nothing then. Bald. Bald tires. You aren't going anywhere.
How much are those